Hi, so for today, we're going to continue our discussion all about calculator techniques for engineering board exam. And for today's video, our topic is all about differential calculus. So, solving the limit or evaluating the limit of a function using calculator techniques. So, this is our very first video on calculator techniques in differential calculus. And for the succeeding videos, we will be also tackling about the calculator techniques in derivatives, okay, in parametric equations, in higher order derivative, and so on and so forth with the differential calculus. So let's start with the limits. So take note, if we are actually solving problems in calculus, okay, we must always we must always convert our calculator into radian mode. Okay, so how do we do that? So as you can see here, we have a letter D here. This indicates that this is in degree mode. Okay, so to actually shift that into radian mode, just simply press shift, and then we have press this button. So as you can see, we have the degree mode and we have the radian mode. Okay, in number 4, just simply press 4. So as you can see, the letter D here disappears and the letter R appears in our calculator, indicating that this is already in radian mode. Again, if we are solving uh, ca differential calculus or integral calculus or any calculus problems using calculator techniques, make sure you convert or set up it in radian mode. Okay, so let's try to solve problem number 1. So evaluate the limit of 1 minus cosine x all over sine of x as the limit as x approaches 0. So the very first thing you're going to do here is uh, first we're going to write the equation on our calculator, 1 minus cosine of x all over sine of the alpha x quantity. And we're going to try to substitute or to calculate this in our calculator with the exact value of x in the limit. Okay, with its limit, which is in this case 0. Okay, so, and we know that that would result into math error because sine of 0 on the denominator would be 0 and the denominator is 0, which is undefined. So, in order for us to calculate this, okay, some of the problems can be solved by directly substituting the value of x, okay? So, if this happens, we must check if the limit exists, okay? So, what are we going to do? Okay, we are going to calculate this limit, okay, by inputting a value of x very near to 0, okay, on the right side and from the left side. So what do I mean? We will input a value of x, okay, a little bit greater than 0 and a little bit less than 0. Okay, so let's try to substitute some value. So we have calculate, okay? So on the right side of the 0, okay, a little bit greater than 0 is 0.0000001. This is technically always almost equal to 0, but it's not 0, but it's near to 0. So this is what we would like to enter on our limit, okay? So as you can see, if we press equal sign, it does not conform to an answer of math error, but rather it solves as a 0. Okay, so we check that. Okay, this value of x 0.00001, okay, is a value of 0 greater than uh, what do I mean? That value that we input is um, a little bit greater than 0. So let's try now to check if the answer or the limit exists still by inputting another value, okay, of 0, which is coming from the left. Okay, so a little bit less than 0. So a little bit less than 0 is negative 0.0000001. Okay, upon entering that, our answer becomes still 0. The limit exists. Okay, so if the limit does not exist, okay, the values that we input from the left and right should not be equal. Okay, if the limit does not exist. But in this case, it exists, and the answer for this problem should be equal to 0. And again, okay, we just input a number slightly greater than and less than to 0 to check if the limit exists. And if they have the same value upon calculating it in our calculator, then that is the answer. Okay? So, I hope you get that what I'm trying to say. So, for problem number 2, x squared, find the limit of x squared minus 16 all over x minus 4 as x approaches to 4. Okay? So, the very first thing we're going to do is to write the function on our calculator and try to directly substitute 4. Okay? So, let's try calculate that with the value of its limit 4. So, as we all know, that's math error. Okay? Why? Because 4 minus 4 would be 0 on the denominator. Okay? So, we will try again our method. So, we have, let me just rewrite that again. Alpha x squared minus 16 all over x, okay, alpha x minus 4. So what are we going to do is to input a number, okay, coming from the left and coming from the right. So a little bit greater than and less than 4. Okay? So let's try the less than, a little bit less than 4. We have to calculate 3.99999. This is a little bit less than 4. Okay? So the value will be 8. Okay? So now we enter value of x to check if the limit exists. We now enter a value of x greater, a little bit greater than 4. So we have 4.00000001. Okay, a little bit greater than 4. And the answer is still 8. So they have the same value, 8. Therefore, the limit exists. And the answer for evaluating this question is 8. Okay, so that's how we check that. It's very easy, right? So, number 4. So, let's try. Evaluate this, the limit of this. X squared minus 4 all over alpha x squared minus alpha x, okay, minus 12. So, let's try to directly substitute 4. Okay? So, that is still a math error. Okay? So, meaning that the denominator would produce a 0 value. Okay? That is a undefined. So, again, let's try to solve this, okay, using our technique in our calculator technique in solving limits. So, minus 12. So, again, this is as x approaches 4. So, we can enter a value slightly less than the 4 first. So, let's try to calculate it. 3.99999. This is a slightly value less than 4. And the answer is this one. So this is very broad. So I will opt to store that into my variable a. So shift RCL then a here. So it has been stored. Okay. So and next thing, we are going to enter value of 4, slightly greater than value of 4. So we have 4.00000001. Okay. And Viola, we have a positive value here. We can store it into B. Okay? So, the answer here, since letter A is a negative, great negative value, okay, and the letter B is a great positive value, they don't have the same what answer. So, the limit does not exist. So, for the limit to exist, okay, these two should be equal. Okay, these two should be equal. Negative, this one is negative, this one is positive. So, the answer here is that the limit does not exist. That's how you are going to check if the limit exists or not. Okay, so let's proceed with problem number 4. Okay, problem number 4. Still the same, evaluate the limit of sine of 1 all over x as x approaches 0. So same thing we're going to do. So we have sine, quantity sine of 1 all over x. And then we try first to evaluate it into 0. So of course, that would be a result to a math error. And now we try our calculator technique. So slightly less than 0, we calculate that. So that is negative 0.000001. Okay. That is 0.3499. Okay. We store it into value of A for future reference or comparing of answers. And now we calculate this to a slightly greater than 0. Okay, so 0.000001. Okay, and that is negative 0.3499. Shift store B. Okay? So if we're going to divide it, as you can see, what we stored in A is positive and what we store in B is negative. So clearly the limit does not exist even though they have the same magnitude but they have opposite signs. So clearly that this limit does not exist because it does not conform to a single value. Okay? So if we divide alpha A, K, and B, it should be negative 1. So that does not exist. So if this is 1, then that's the value, that's the answer. But since it's negative 1, which the result should be 1, so it does not exist. Since they do not have the same value, okay, this is positive and this is negative, then the limit does not exist. Okay? So problem number 5. So, problem number 5, evaluate the limit of 3x cubed minus 4x plus 2 all over 7x cubed plus 5. So, let's try to rewrite that first. 3x cubed minus 4 alpha x plus 2 all over 7 alpha x cubed. And then we have plus 5. So, the limit now is into positive infinity. Okay? So, what are we going to do? Instead, we're going to calculate it giving a value of x a very large amount of value. Let's say this value. Okay? Numerous 9. A very large amount of value. So, the answer is 3 all over 7. Okay? So, take note that this is a positive infinity only. So, we have to substitute a greater or a very big value in a positive only. Okay, so the answer here is 3 all over 7. Again, what we have used is this value, large value, in substitute with infinity. Okay, so that is 3 all over 7. So that should be the answer for our problem. Okay, so it's fun, right? Even though you don't really know the concept of calculating the limits, just as long as you have your calculator and you have the choices, okay, you can easily calculate this limit using the calculator techniques. Okay. So for problem number 6, the same thing that we're going to do. So we have sine of 3 alpha x. Then we have alpha x on the denominator. So obviously, if we substitute directly 0, this would be math error. Okay. So we will again solve this using our technique. Less than, slightly less than, is slightly greater than 0. So let's start with slightly less than with a negative 0.000001. Okay. So that is 3. Let's check if we substitute it from the right, a little bit greater than 0. Still, if that is 3. Okay, so we have 0.000001. That is still 3. So the limit exists, okay? And the answer would be 3. Okay? So because they have the same answer coming from the left and coming from the right of this 0 in the number line. Okay? So, okay. So for problem number 7, of course, we have this. We have sine of 2 alpha x all over sine of 3 alpha x. Okay? As x approaches 0, then definitely we know if we substitute directly 0, this would be undefined or math error. So that is still the same technique. Calculate it. So we have slightly less than 0, negative 0.000001. That is 0.667. Okay. Store that in our variable a. And next, we have to calculate, okay, on the right side, which is a slightly greater than 0. And still, that is 2/3 or 0.6. Okay, 0.667. So let's just try. Okay, that is still 0.667. So our answer here, of course, would be what? 2/3. Okay, so because if you evaluate 2/3, okay, that is the answer. Okay, so we have letter C. So the limit exists, okay, and the answer is 2/3. Okay, so for problem number 8, evaluate this, the limit of tangent cube 2x of 2x all over x cube as x approaches 0. So how do we do this? Okay, so this tangent cube 2x is similar to quantity tangent of 2 alpha x. Okay, be careful with the parenthesis. This is the parenthesis enclosing the 2x, and you have to add another parenthesis and raised to 3. That this one is the same as this. Okay, so that is the same all over x, then we have cube. Obviously, if we substitute directly 0, the result would be math error or undefined. Okay, so the same technique coming from the left, negative 0.000001, okay, is 8. And coming from the right, a slightly value greater than 0, 0. Oops, we have 0.000001 is still 8. So the answer, it conforms to the same answer, which is 8. So the answer here should be 8. Okay? Okay, how about this? The limit of 1 minus sine squared x raised to 1/2. So let's try to do this. 1 minus, okay, sine squared x. We have sine, okay, of alpha x quantity. And then we have squared here because of what? Because of the sine squared here. And another quantity, okay, raised to 1/2 or 0.5. Okay? Take note or be careful with the parenthesis. This parenthesis is for the whole equation, and this parenthesis is for the sign, and this parenthesis is for the x. So as x approaches 0, so we need to calculate that again from the left side. So that is 1. From the right side, slightly greater than 0. That is 1. So the answer is 1. It's very easy, right? So you can calculate any type of limits if you just know how to calculate it using the calculator techniques. Of course, in our study of differential calculus, when we are still students, okay, uh, we need to factor out or apply some trigonometric identity in order for us to solve the limits, or even uh, try some algebraic manipulations in order for us to solve the limits. Okay, but having the knowledge of calculator technique is very powerful. Okay, again, calculator techniques is only useful if what? It is multiple choice. Okay, so if that is not multiple choice, then calculator techniques would not simply work. So I'll give you this problem. Okay, I'll give you some time, 30 seconds, okay, to just solve this, okay, on your own. And please identify the answer. Okay, are you done? Do you have an answer? Let's try to check this. So the very first thing we're going to do is still obviously enter the expression in our calculator. Okay, that is the E here is found here. So it has a red mark. So we have to press first alpha, then this sign of the exponent or the scientific notation, and then raise this into x as we have seen in the expression. Okay? So as x approaches 0, so the limit of x all over 1 minus e raised to x as x approaches 0. So we have to solve 0 first. Let's try. Math error. Okay? So again, solve this using our calculator technique. So we have negative 0.00001. We have negative 1 with a values of 499. Technically, if we round this up, this is still negative 1. And we solve that slightly greater than value than 0. So, negative or is negative 0.9995. So, it doesn't mean that the limit does not exist. Okay? So, as you can see, if we round this off, negative 1, and if we round this off, that is still negative 1. So, for more accurate, let's try to be more closer negatively or from the left from 0. And that is technically negative 1. And let's try again coming from the right, more closer to 0 by adding more zeros. Okay, we get negative 1. So, technically, the answer here should be negative 1. Okay, that's it. I hope you learned something from this video. Thank you so much for listening. I hope you had fun, okay, in learning this calculator techniques involving the evaluating or evaluation of limits in differential calculus. If you are new to my channel, please don't forget to check out my videos. Okay, I have differential equations, integral calculus, physics, um, and some of the major subjects in engineering. So you can check it out also. And if you haven't watched the previous calculator techniques, so please do so. Just look it up on my playlist of calculator techniques. Okay, so thank you so much for listening. I hope you pass your board exam and get that license, okay, at the end of the day when you take the board exam. Okay, so thank you so much and God bless.